everyone, it's Alyssa and welcome to You Can Learn Math. So today is about geometric sequences. I previously did arithmetic sequences. That is when you have something being added each time, like for instance, 1 plus 4 is 5, plus 4 is 9, plus 4 is 13, plus 4 is 17. If that's the kind of sequence you're dealing with, that is an arithmetic sequence. Looks like arithmetic, sounds much posher. And you can find a link to that in the description below. This one today is geometric sequences. Geometric sequences are when things are being multiplied. For example, 2 times 3 is 6, times 3 is 18, times 3 is 54, times 3 is 162, and so on. Right off the bat, you can see they get a lot bigger, a lot more quickly. We're talking about like exponential growth, things growing very quickly. In here, it's being, multiplied order of 3, or times 3 each time. This is why in the arithmetic sequences, you might have a question like, what is the 50th number in this chain? You're not going to see things that high in a geometric sequence, mostly because your average calculator can't handle it. The number just gets too big. And you end up with something like, 8.2 times 10 to the power of 67. It gets insane if you go too far down the line. So what we're going to do and deal with today is the formulas for geometric sequences. And the two types of formulas, just like with the arithmetic, there's two types. You have your general main formula, and then you have a recursive. The main one, it stands alone. It stands there and it's like, yes, I am the general formula. You can tell everything from me. Haha, you need nothing else. And the recursive formula is when you know the previous term and then the next term kind of is leaning on it and saying, okay, you know what I am because you know what the previous term is. It's supposed to be leaning. Yeah, my stick figure game is not up to point. Or it's not on point, up to point. Up to par, on point, you know what I mean. So first, the general formula. This is what it looks like. And it's going to look a little crazy, but when we break it down, I promise it's not that bad at all. Okay, so first, this we would read as A sub n. A sub n. What this n means, and it occurs twice in this formula, that n is referring to the position of a given number. For instance, let's say I had a formula or sequence, where things are being multiplied by 2. 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and so on. This is the first number in the sequence. Why do I keep saying formula? This is the second number. This is the third. This is the fourth. This is the fifth. This is the sixth. Yay, I can count. So this would be right here, A sub 2. It is the second number. This one here would be A sub 4. It is the fourth number. And so on. That's all that n represents, is the position, the place in the sequence of this number. This is true for arithmetic and geometric. That's what the n means. R is our ratio, what we're multiplying by each time. And A sub 1 is, oh, you guessed it, the first number in the sequence. Because like we just said, that's what that means. This number means where, the little sub means where is it in the sequence. So for this equation, I can't talk. This sequence. For this sequence, let's fill in the blanks. Now when we're writing an equation or formula for a sequence, There's only two things we have to fill in. What the first number in the sequence is and what the ratio is. This bit, the a sub n and the n minus 1, do not touch it. If you're writing a general formula, leave it be. See, I told you this would be easy, right? You leave the a sub n. A sub 1 just means the first number. In this case, that's just 1. Our ratio, and I'm going to multiply this. I'm putting a little dot to indicate I'm multiplying. My ratio is 2. I am multiplying by 2 each time. And then I leave to the n minus 1. And that's it. I've written it. Now, why does this work? Why is this? What is actually happening here? 2 to the n minus 1. What is going on? Well, let's say what's happening with each term. So our first term in the sequence is 1. Our second term is 1 times 2. Our third term, we could say it's 1 times 2 times 2. Our fourth term, we multiply by 2 again. Every time, we're just adding and multiplying another 2. Fifth term, 1 times 2 times 2 times 2 times 2. Well, what's another way of writing things like 2 times 2 or 5 times 5 when I have that same number, multiplying by itself? Well, it's a power, right? An exponent. So let's see what we can replace here. I can replace 2 times 2 with 2 squared. 2 times 2 times 2 is the same as 2 cubed. 2 times 2 times 2 times 2 is 2 to the 4th. And looky there, we've got a pattern emerging. And we can say, we don't normally write it this way, but we absolutely can say that just 2 is 2 to the 1st. And look at this. The third term is 1, which is the first number, times 2 squared. And look, 2 squared, that's 1 less than 3. What's our fourth term? It is 1, the first term, times 2 cubed. And hey, look, 3 is 1 less than 4. What's our fifth term? Our first term, 1 times 2 to the 4th. And look, 4 is 1 less than 5. So that's where our sequence comes. First term times our ratio, in this case it's 2, to the power of 1 less than the number, the position you're trying to find. And if you're wondering, but what about the first term? It works here too, because this is the same as 1 times 1, and 1 is 2 to the 0. Or in this case, 2 to the 1 minus 1. So it works all the way down. Okay, now how about a recursive formula? Recursive is the one which is kind of like it's the formula for what we do if we're just looking at a sequence. If you were given this on a test, let's say you were given 1, 2, 4, 8, and they asked you to do the next 2, I sincerely doubt that you would, worry about trying to create a formula like this and then figure out those 2. No, that would be unnecessary. What are you going to do on that test? You're going to go, 1 times 2 is 2 times 2 times 2. Oh, I see the pattern. What's 8 times 2? 16. What's 16 times 2? 32. You used a recursive formula in your head, even though you didn't call it that. You took the previous term and multiplied it by the ratio. Then you took the previous term and multiplied it by the ratio. That's all you did. So let's write the formula for that. So let's just kind of think about it and see what it might be. You might go, okay, so if I want to know a term, I need to take the previous term and multiply it by the ratio. Remember, n means what place it is in the sequence, what term number it is. So if I was saying a sub 5, what would the previous term be? A sub 4, right? Or, using our little terminology we like, we could say that was n minus 1. 5 minus 1 is 4. And then what do you do with that previous number? I would multiply it by, what was my ratio up here? 2. I multiply by 2. That's my ratio. So, ratio. That's it. That's all it is. This is literally a very fancy way of saying if you want to know the next number in the sequence, take the previous number and multiply by a ratio. Now, if you just are presented this and say write the sequence from it, you couldn't because you don't know what the first number is. You say take the previous number. Wait, what was the previous number? I don't know. That doesn't work. So it also has to tell you, just like with the arithmetic, what is the first number in the sequence. And that could be anything. So for this sequence right here, let's take a look at it. We would say a sub 1 is 1. So you have to tell the person first what it is. And just like with this one that's up here, we leave the a sub n and the n minus 1, we leave that alone. And in this case, we'll see like up here, we had to fill in a sub 1 and the ratio. That's all we have to do over here as well. We fill in a sub 1 and the ratio. That's it. Don't touch anything else. So, second part of the equation, a sub n equals a sub n minus 1. Again, I don't touch any of that. What's my ratio? It's times 2. So, right? Times 2. And that is the recursive formula for this sequence. So just to show you the other way around, if they were to give you, because that's how you get the sequence, the formula from the sequence, let's get the sequence from the formula. Let's say they gave you a sub n equals 5 times 3 to the power of n minus 1. Well, this is a general formula, and we know for a general formula, a sub 1 times r to the n minus 1. If we look at this general formula, my number here without an exponent is a sub 1, or the first number in the sequence. So I know the first number in the sequence is 5. Then I know that the number that's being put to a power is my ratio. So that means this is my ratio up here, 3. So I know I need to multiply each one by 3. So the next number in the sequence would be 5 times 3, or 15. Next one would be 45. Next one would be 135, and so on. What would the next one be? 405, I think? I have to double check that. Not the best at multiplying in my head, but I try. Yeah, it's like 300, 393. Yeah, okay, 405. I'm pretty sure that's right. So there's our sequence. This same thing, they might give it to you like this. They might say a sub 1 equals 5. A sub n equals a sub n minus 1 times 3. Same information is being given. They're telling you what a sub 1 is. They're telling you the first one in the sequence, so that's 5. And our formula, our recursive formula, we know that this number that's out, no, don't erase, I wanted to highlight. This number that's out here is the ratio, so that's my ratio, 3. So I know to multiply by 3, 5 times 3, again, 15. 15 times 3 is 45. 45 times 3 is 135, and so on. And that's how you do geometric sequences. If you have any questions on this, please leave them in the comments below. If you have any suggestions about future topics, always glad to hear those. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.